let's just move on further towards some of the sums that are based on the elimination method. Question number 1 says that solve the following pairs using elimination method. So for the very first part, we have to find out the value of x and y. So let us suppose if we are making this as equation number 1 and we are taking this as equation number 2. Now let's just follow the steps in order to solve the value of x and y of the elimination method. So the step number 1 would be of the form, either we have to make the coefficient of x as same, or either we have to make the coefficient of y as same. So as we can see over here, we have the y coefficient in the very first equation is 4, and in the second equation we have the coefficient of y as nothing but 2. So we can make them similar. As we can see over here, we have plus of 4y, we have minus of 2y. We can make them similar by multiplying minus 2 with the second equation. We can make them similar by just multiplying minus of 2 with the equation number 2. So let's just multiply minus 2 into equation number 2 in order to make the equation number 2's coefficient of y variable same. So if we are taking minus of 2 and we are multiplying with 2x minus of 2y is equal to 2, we will get the equation as minus of 4 of x minus 2 is nothing but plus 4y, which is equal to minus 2 into 2 is nothing but minus of 4. Let us suppose I'm calling this as third and I'm taking the first equation as it is over here. So we have the first equation as nothing but 3x plus 4y, which is equal to 10. So this is my first equation. Now the step number 2 is of the form, we have to subtract these two equations. Subtract equation number 3 and 1 in order to get the value of y or x. So we have minus 4x plus 4y, which is equal to minus 4, 3x plus 4y, which is equal to 10. As we are subtracting, so the signs would be changed. So it means 4y get cancelled with each other. We will get minus 4x minus 3x is nothing but minus of 7 of x, which is equal to minus of 14. So negative and negative get cancelled with each other, and at the end, what is the value that we are getting? We are getting x as nothing but 14 by 7, which is nothing but 2. So at the end we are getting 7x is equal to 14. It means x is nothing but 14 by 7. 14 by 7 means 2. So we are getting x is equal to 2. So let us suppose I'm calling this as nothing but the equation number 4. Now we can substitute any x is equal to 2 in any equation, whatever we want, in the equation number 1, either in the equation number 2 either. So let us suppose I am just substituting x is equal to 2 in the equation number 2. So let us suppose substitute equation number, let us suppose we are substituting equation number 4 in second equation. So let us suppose if we are substituting the value over here, so it would be 2 into 2 minus of 2y, which is equal to 2. So this is 4 minus 2y is equal to 2. Further we have minus 2y is equal to minus of 2, because minus 4 plus 2 is minus 2. Minus and minus get cancelled with each other. Y is nothing but 2 by 2, which is 1. So at the end, what we are getting? We are getting the value of x as 2 and y as 1. So x is equal to 2, y is equal to 1 is nothing but the solution for this particular pair of linear equation. Now let's just talk about the second part. So in the second part, we have x by 2 plus 2y by 3, which is equal to minus of 1, and the second equation is x minus y by 3, which is equal to 3. Now first of all, let's just solve these two equations. First of all, let us suppose I am solving this equation. As we can see, we have 2 and 3. We can take the LCM of 2 and 3, which would be nothing but 6. So the equation would be of the form 3x plus 4y, which is equal to minus of 1. So if we'll take 6 toward the other side, the equation would be 3x plus 4y, which is equal to minus 6. Let us suppose I'm calling this as equation number 1. Now let's just talk about the second equation. If we'll solve the second equation, we can take the LCM over here, as x is nothing but x by 1. So the LCM of 1 and 3 is nothing but 3. So this would be 3x minus of y, which is equal to 3. Now let's just multiply 3 with 3. We will get the value as 3x minus y is equal to 9. So this is nothing but our second equation. Now first of all, as we can see, both of these equations do have the coefficient of x as similar. As we can see over here, we have 3x plus 4y which is equal to minus 6. 3x minus y is equal to 9. So there is no need for the step number 1. There is no need for the step number 1 because we do know that the coefficient of the variable x in both of these equations is similar. So now in order to solve this equation, we are saying that we have to subtract equation number 1 and 2. So rather than moving on for the step number 1, instead of making the coefficient same, so as we can see, both of the coefficients are already same. We do not need the step number 1. So we are skipping to the step number 2, in which we have to subtract both of these equations. So it means we have 3x plus 4y which is equal to minus of 6 and 3x minus of y which is equal to 9. As we are subtracting, so signs would get changed. 3x and 3x get cancelled with each other. We'll get 4y plus y which is nothing but 5 of y, and further we have minus of 9 and minus of 6 which is nothing but minus of 15. So it means that the value of y we are getting is nothing but a minus of 15 by 5 which is 3. Means the value of y is nothing but minus of 3. So as we have y as minus of 3, we can able to find out the value of x by substituting it in any equation. So let us suppose we are substitute equation number 3 into, we are substituting into, so we'll get the answer as 3x minus of 3 is equal to 9. This is 3x plus of 3 is equal to 9. 3x is equal to 9 minus 3 which is equal to 6. 3x is equal to 6 means x is equal to 6 by 3 which is nothing but 2. So at the end x we are getting as 2. So hence the answer for the second part is x is equal to 2 and y is equal to minus of 3 using the elimination method. So this is all about solving the pair of linear equation using the elimination method. Now let's just move on further.